in part 1 of this lesson, we looked at how to evaluate equations in function notation. We're going to move from equations now to using graphs to evaluate function notation. When we read a graph, we are looking for inputs and outputs. All of the inputs and outputs are represented by the line. So we're going to use these function notation expressions to locate a point on this line and find the missing value that goes with it. Remember, function notation can show both the input or the output of a function. If we interpret the function correctly, we can evaluate or solve. We may do one or the other. Here we have a 1, so it says f of 1. That 1 is in parentheses, so it is our x value. When we come and look over at this graph, this part right here is 0. This is the middle. This graph is a little bit hard to read, but what we're going to see is 1 is right here. This is 1. So if we go to x equals 1, we're going to look up or down until we find that spot on the line, which takes us right here. That output is 1, 2, sorry, let's do this. 1, 2, 3, 4. We can also see that as the y value. So f of 1 is 4. What about f of negative 3? Well, again, this negative 3 is in parentheses, so it's our x value. We're going to look at the x-axis again. I'm going to number this for us. This is going to be negative 1, negative 2, and negative 3. We're looking at x equals negative 3, and again, we look up or down until we find the line. This portion of the line, this point on the line, has the correct x coordinate of negative 3. We can look over to the y-axis. If that was numbered, we would be able to see it there, or we can count. So this would be negative 1, negative 2, negative 3, and negative 4. Again, these are negative because we're going down in the y direction. So this would be negative 4 for our output on this point. How about f of 0? F of 0, this is in parentheses, so it is an x value. X equals 0 is right on the axis. We look up or down. There's our point. We went up 2 boxes. Our y coordinate is 2. Again, there's a relationship here. This input of 1 gets you an output of 4. This input of negative 3 gets you an output of negative 4. An input of 0 gets you an output of 2. We can use graphs to go the other direction as well. We can take the output and match it with the input. Suppose we have f of x equals 2. We want to find the values of x, right? It says solve for the following values of the input. Here, we don't know what x is. It's a question mark, but we know that the output, the y value, is 2. So here's 2 on the y-axis. Y coordinates tell you how high up you're going to go, so it's sideways for this line. These are all the y equals 2. This is that level. And then we look and we see that that line would cross here, but also here on the graph. We have more than one more than one input that could get us this output, which again is fine. We're not lined up vertically. These are side by side. One of those points is at 0, so we can go ahead and say x equals 0 is one of our answers. The other answer, we're going to add some numbers to this axis here. If we look at this point here, it lines up with 3. So our other solution is x equals 3. Either one of these inputs would get us this output of y equals 2. One last example. Again, we want to remember that the number in the parentheses is x. In this case, our x is unknown. But what we do know is that y equals 0. So here's y equals 0. Because it's a y-coordinate, we look side to side. And we want to look all the way across the graph because I find that there are 3 points that work here. That we have one at x equals -1, x equals 4, and then if we keep counting out, we could see 5, 6, 7. X equals 7 is our last answer. This concept can be tricky. I would tell you to focus more on evaluating with the graph, using an input to find its matching output, and not to focus as much on the solving portion. Now that I've done these examples, do the check-in down here. Again, when you finish, you can take a picture of that and email it to Mr. Bechtel, and he'll check your work.